we have seen two approaches. First was using the slowly changing dimension. The second is using the lookup transformation. And the third approach that we are going to see is using the merge join transformation. So lookup and merge join, they have similar kind of operations. They do the same kind of task. You just need to configure them differently. So this is my incremental merge transformation. Just click on it. And this is how it will look. Okay. So we'll see it is kind of similar to the lookup transformation. It's only some different stages here and there. So the very first step, obviously, reading from your flat file source. Okay. So I'm reading from my flat file source, same file I'm reading from. I have configured my columns and so on. So, okay. Now the second step is to read from your dimension table. So because you're using a merge join transformation, you have to define your OLEDP source over here with the dimension table. So now I'm going to read from my dimension table, and I am going to perform a similar kind of query over here. I'm going to select my columns, and then I'm going to say, okay, we'll see what this means. One as dim record. And the same filter I've used where end date is null, because I only want to be checking my current columns. Okay, so the current columns are identified, the current records are identified by end date is null. And then I have ordered by my first name and last name. So if you remember, merge join has a requirement that your input source data should be sorted. Okay, so merge join has this requirement that your incoming source data should be sorted. That is why I have included an order by. And this is very important, because if we do not sort this data, then the results of this transformation might not be reliable. So we have to make sure that we sort this data. So order by, I have added an order by first name and last name. Now you'll also see that I have added one more column over here, and it is called a dim rec column, and I have given a dummy value to that column. So that dummy value is simply to identify later on whether it's a new insert or not a new insert column. And I'll explain later on when we get on to that task. Okay, so for now, just remember the same query we need to use where end date is null to select only the current latest records from the dimension table and not the historical records. Second point to remember over here is you need to order by your data by your key columns, because merge join has a requirement that your incoming data should be sorted. If it is not sorted, then you might end up with incorrect results. So do that. Okay, columns and all that. Now we have already seen the merge join state. So if you remember, you have to go to your advanced properties, go to column mappings. Okay, this is simple. Input and output properties in your source output for the output columns, or the source output. Okay, make sure that you set this is sorted property to true. By default, it would be set to false. You have to set this to true. Otherwise, you will not be able to use a merge join stage. Simply does nothing on its own. It simply indicates to the next task, which is a merge join task, that your input is sorted. But you have to explicitly sort your data. Okay. Once you say is sorted is true, then you have to go to your columns and give them a sort key position as 1, and then last key, sort key position of 2 for the second column that we're using. So you have to perform these two operations. Go to the advanced editor, go to the output, set the is sorted to true, then go to your output columns, the columns on which you have ordered by, give them sort key positions as 1 and 2. Okay, so this needs to be done for any database source that we are reading from. Okay, and not doing a sort using the SSIS. If you're doing a sort using the order by statement of the SQL Server, you have to set all these properties. Now for the flat file, order by cannot be done at the source level, so you have to use an explicit sort transformation. Once you use a sort transformation, you just specify your columns on which you are sorting and your sort type, ascending, and your sort order. You specify it over here. Okay, 1 and 2. Say okay. And then you can join with your merge join stage. Okay. There you will not need to set your is sorted property to true. It would be set to true by default. Okay, because this is a sort stage, so it will set it by default to true. Okay. And now we have given both these inputs to the merge join transformation. The merge join transformation can perform a left join, a right join, or a full outer join. Now we are going to perform a left outer join over here. And now when we are going to perform a left outer join, which source should we keep as the left link, as the left source input? The left source input we would be keeping as a flat file data, because that is the data which would have some new records, which would have some updated records. So our requirement is to read all the records from a flat file. So we are going to keep that as the left link, and then going to perform a left outer join. So that would ensure that we take all the records from our input source file, whether they are new records or updated records. Now, how will you identify if they are new records or updated records? Now, in terms of merge join, you will get one output link, and then based on that, you have to identify. To identify, I need to use another transformation stage, which is called the conditional split. Now, we've seen this one earlier as well. Let's double click on that and see what we have done. So now, I have identified two records, insert records and update records. The insert record is simply I have identified as is null dimrec. Dimrec is what? Dimrec is one of the incoming attribute columns. Okay, from the dimension. So let's go back to the merge join. In the merge join, we have joined on the key columns, first name and last name. Okay, and then we have taken all the other columns, the output, whichever we wanted, from the left link. So I've taken all these columns from the left link. Title, email, address, phone, department name, wherever I wanted to do a check. I've dropped gender for now because that would be too many columns. So I have dropped gender for now. So title, email, address, phone, and department name. These have been taken from the left link. Now I've also taken columns from the right link, which is the OLEDB source. And I've taken the same columns from the right link, title, email, address, phone, and I've renamed them to indicate that they are from the dimension. So I've just prefixed them with dim. So dim title, dim email address, and dim phone, and so on. And then I had one additional column in my dimension table, which had a fixed value of 1, as we saw in the query, and I have called as dimrec. Okay. Now, when I go to the conditional split to identify the insert records, I have checked for null values for the dimrec column. Okay, so what is the use of this dimrec column now? Because we have performed a left outer join, what will happen for any insert records or any new records? So new records are the ones which are present in my source file, not in my dimension table. Now I perform a left outer join between my source data and my dimension table. What will happen is all the records from the source data will be read. If there is a match with the dimension table, then they would take the attribute values from the dimension table. Otherwise, in cases where there's a record which is present in my source data and it did not find any match in the dimension table, we will have values for all the columns which are coming from the left link. So I'll have a first name, I'll have a last name, I'll have a title, I have an email address. But for these columns which I have taken from my right link, which is a dimension, now the dimension did not have this record. So all these columns will have a value of null because there was no match found in the dimension. Therefore, null values will be populated for all these columns. This is how a left outer join works. Now, what was the need to add an addition column in that case? I could have simply checked for null value in any of these columns. So if there was a null value in any of these columns, that means there was no record found in the dimension table and it is a new record and it needs to be inserted in the dimension table. So the advantage of adding a dummy column with a constant value is that all these other columns are nullable columns. So null is a valid value in these columns. So it might happen that there was a record and all the attribute values were null. And now when I try to check that whether the dim title was null, a null could have been a valid value. So it could actually have been a record which was an update record. And since I checked on the null value for this record, it got identified as an insert record. Okay. So what it basically means is that my record in my source data also had nulls for all these attributes. In my dimension also, there was a matching record with nulls for all these attributes. Okay. So there were nulls for all these attributes, and now I'm checking whether it's a null to identify a new record. Then it is not a true condition, because even for updated records, these columns could have been containing null values. That is why I've added a dummy column which will always have a value of 1. So if you drag it from the dimension table, this record, even if if it is a matching record, that column would always have a value of 1. It is a not nullable column because it is a not nullable column. Now, if it is a new record which needs to be inserted, which means it is only present in the source data, not in the dimension table, then this record will have a value of null. So this column will have a value of null only in one case, which is when the record is present in the source file but not in the dimension table. So that is why I've used this particular record, and I've done a conditional split on that. And for identifying the insert records, now I'm checking if is null dim rect. Null functions, again going back to the null functions, this is your function that I have used. You just need to give your input column name over here. So this identifies all the new records which need to be inserted into the dimension table. Now, how to identify the update records? Now, if you remember, in the lookup transformation, we performed two lookups. One was on the key columns, and then the second lookup was on all the attribute values as well. So we are going to write that because we can actually put some expression here in the conditional split transformation. We are going to put all that logic into one expression. And this is the expression that we have created. The first step is to identify that it is an update record. So it is an update record. That means it exists in the source data as well as in the dimension table. What is the way to identify that? That means this column that I have added with the constant value dim rect does not have a null value. So this is how you identify a not null. Okay. Use a is null function. Then go to your operators. What is the operator for not? So you have to go. This is a logical not, an exclamation mark. Use that in front of your function. So is null dim rect. Okay. So this with an exclamation, this simply means is not null. Okay, because there is no is not null function available in your null functions. So you have to use is not null over here. Okay. So this is simply checking that the dim rect column does not have a null value. Does not have a null value, that means it is an update record. That means it is already present in the dimension table. Now the next step is to check if there is a change in any of the attribute values. So the second check, combine the second check using an AND. Okay. So this is a logical AND. Use that AND over here. Give a bracket because there are going to be a series of conditions now and we want to check them all together. Title, which is a column coming from the source input, is not equal to, this is your not equal to symbol over here. So these are your SQL Server database commands as well. So not equal to dim title. Okay. So title that is coming from the source input file not equal to the title coming from the dimension. This is your OR. Okay. So you can see this is your logical OR. Okay. This symbol is your logical OR, two parallel lines. Email address not equal to dim email address, or phone number not equal to dim phone number, or dim department name not equal to your department name. So combine all these attribute checks into one check within one bracket and combine it with the first check, which is not null or dim rect. Okay. So this is basically how you would write it. I'm going to paste it in the chat window as well. Okay, this is how you would identify an update record. Say okay. And then the same kind of operation. Now I have identified my insert records and update records. The insert records go over here and the update records go over here, and I update them using an OLEDB command. So the same command I've used, update dim employee. Okay. Set end date equal to get date, where first name is whatever, end date is also same command over here. And then union with the update records as well as the insert records. Go to the derived column derivation, same derivations. Set the start date and the end date as new columns, and then go to your destination stage and insert them into your table. Okay. So this was dim employee 1. Let's change it to dim employee 2 now. So you can see how you can use that dummy column. You can just include one as dim rack. Okay. I'm going to paste this query as well in the chat window. Okay. So I'm just changing the table names again because we have already inserted into the other tables. So this is just a replica of that table. Dim employee 2. Okay. And dim employee 2. Okay. Save it. Let's go back to the database and check what is in dim employee 2. Execute. Okay, same kind, employee key is null, that's okay. Same 2 records for David Bradley and so on. Okay, so similar data, same data is there. Go back to the control flow. Right click and execute task. Okay, it's a green tick mark over here. Go to data flow. 3 rows, 18 rows came from your dim employee table. 3 rows went after the join to the conditional split. 1 row went as an update. 1 row went as an insert, and then okay, 3 rows were inserted. Okay. Okay, we'll see what happens. Okay. And 1 row was updated. So let's go back to our table and see what happened. So David Bradley, you can see the old record got undated, same way, and then there was a new record inserted, okay, with a value of null. Then for Kevin Brown, okay, now 3 records have been inserted here because we did not make a check on the gender value, so you can ignore it for now. What we want to check is for David Bradley, this record was undated and the new record was inserted with the new attribute values and the end date as null. So the email ID has been updated because we did not make a check on the gender column. It has been updated as null. That's why a new record has been inserted. Now for the other, Adam Owens, this column, a new record has been inserted with current date as today's start date and the end date as null. Okay, so this is how we wanted it to perform. So this is how you will design your ETL design using the MergeJoin transformation stage for the slowly changing dimension. These are for type 2. If it is type 1, then it's simple. You just go and update your records and you just insert your records. So then you do not need to collect your update records for inserting as a new record. You do not need all these derivations. Okay, type 1 is simply going and updating the same record because there is no history that we are going to maintain. Okay. So these are the two approaches. The other approach, as we have already seen, is a slowly changing dimension. The fourth approach is using the database itself, if you can.